Good morning, everyone, and welcome to today's SMI Showcase webinar. At Steam Management, we support facilities nationwide with full-cycle steam system solutions, from assessments and ECM development to engineering, project management, and turnkey installation. We serve a wide range of markets, including K-12, municipal, higher education, federal, healthcare, and industrial facilities, and we frequently work under performance contracts and are excited for the topic of discussion today. Today's session is titled Energy Savings Performance Contracts, Essential and Emerging Opportunities, and is presented by Dr. Timothy Unruh. Dr. Unruh will walk us through the foundational and emerging concepts of ESPCs, things like project leveraging, grid interactive efficient buildings, energy as a service, and NAESCO's SCIP legislation initiative. These topics are becoming increasingly important as customers push for deeper savings, decarbonization, and long-term infrastructure modernization. For those who don't know me, my name is Chase Bean, Vice President of Revenue and Engineering at Steam Management. We host these webinars to support our audience with practical insights into utility system efficiency opportunities and performance contracting strategies that drive measurable results. You can find recordings of past sessions and register for future webinars at steammgt.com/webinars. We're honored today to be joined by Dr. Timothy Unruh, Executive Director of the National Association of Energy Service Companies. NAESCO is the leading advocacy and accreditation organization for ESCOs and is dedicated to modernizing America's building infrastructure through performance contracting. Uniting the energy service industry, NAESCO promotes favorable government policies, sponsors a rigorous accreditation, provides training and education, and champions ESCO's interests across the nation. Dr. Timothy D. Unruh is the Executive Director for NAESCO. In this role, he manages the national representation of its member energy service companies. Prior to NAESCO, he served as the Deputy Assistant Secretary of Renewable Power at the U.S. Department of Energy and previously directed the Federal Energy Management Program, managing federal sustainability and energy efficiency initiatives. Before his federal service, he spent many years in ESCO operations, most recently as the Director of Operations for Con Edison Solutions. Dr. Unruh holds bachelor's, master's, and doctoral degrees in electrical engineering from Wichita State University, and we are fortunate to have him here with us today to share his expertise. Dr. Unruh, thank you again for joining us. The floor is yours. Oh, you're muted. Sorry.
I guess first of all, just to tell you a little bit about who NAESCO is and give our agenda together of what we're going to talk about today. So we're going to talk about NAESCO and the ESCO industry history. We'll talk about what is an energy savings performance contract. So I know we probably have a wide array of audience attendees that some will know what that is and some will not. So we'll talk about that. I've got a sample project that kind of highlights some of the things we'll talk about today to give you an idea of some of the angles you can take with an energy savings performance contract. We'll talk about project leveraging, which has been on my agenda for like the last 5 years. Grid interactive efficient buildings, which is something that was pioneered back at the Department of Energy when I was there. Energy as a service, the new thing that everyone's talking about, and NAESCO's take on energy as a service, what we call SCIP. So our learning objectives today, in order to make sure that we follow all the continuing education requirements, we want to learn how an ESPC works, an energy savings performance contract. We want to understand the role of financing in building projects. We want to realize the opportunity for leveraging funding in an ESPC. And I'll show you an example of how that works. And we want to learn how new contract structures can benefit building retrofit projects. If I do my job right, we'll know all these things when we get done. So NAESCO, the National Association of Energy Service Companies, we're a nonprofit trade association, and we specifically advocate for the energy service company market. So our members primarily are energy service companies, and then we have what are called affiliates, which are those companies that sell goods and services to energy service companies. We also have a few other members. We have some government entities that have joined us. We have some other nonprofits that have joined us because they believe in the mission and they're involved in the mission. We've been around since 1983. So what is that, like 40 some odd years we've been around. So it's not a new organization. I've been here 7 years, but we've been around for quite some time. Today, we have a membership of 172 organizations. And what's unique about us is we are the home of the only energy service company accreditation in the United States. We've worked with a group called the Global ESCO Network to help get energy service company accreditation spread worldwide. And there's a lot of advocates, not just myself, but others, about having an energy service company accreditation. We feel that accreditation is an important piece of the mission because a lot of times the selection process for energy service companies is done on reputation and past experience because you can't really do a bid process, as we'll see in the whole development phase. And so having an accreditation program to know who is a proper company to work with is very important. Today, we have 22 accredited ESCOs as members, 14 accredited energy service providers, which are those who provide ESCO work and energy supply services. And we have 4 accredited contractors. These are companies that have been accredited to do energy efficiency work for our ESCOs. So to give you a picture of some of our ESCO members, I put a slide together that has all the logos of our ESCO members. And what's unique about our membership is that we have companies that are extremely large. So you can see right in the middle there, there's Siemens and there's Honeywell. And then off to the left, we've got companies like ABM and AECOM. Those are all very large companies. We've got a group of medium companies that do work. We have Verigy. We have like DCO Energy and Energy Efficiency Investments, EEI. And then we have some companies that I'll call smaller and regional companies. And those are companies like ESP in the upper right-hand corner, or Navitas. They're companies that do more localized work, but they have branches across in various states across the country. And so we have the ability in our industry to compete against one another and to do work from a small company to a large company, each with their own attributes and benefits that they work with. So what is an energy service company? An ESCO, as you'll hear me call them throughout this entire presentation. I'm just going to read this. This is a new definition that our board has approved as of last month. An energy service company, ESCO, partners with facility owners to develop, deliver, finance, and/or own energy and infrastructure modernization projects funded by operational cost savings, incentive dollars, and/or client capital. An ESCO can provide guaranteed performance and ongoing monitoring, as well as the operation, maintenance, evaluation, repair, and replacement of assets through a multi-year performance-based contract. So notice it doesn't say that they do ESPCs, Energy Savings Performance Contracts. They do performance-based contracts. And the performance-based contract, as we'll see later, can be energy as a service, can be something we call SCIP, Sustainable Capital Improvement Project. It effectively means that there's some accountability over the life of the contract that the energy service company agrees to. And the other piece that's important is the funding sources. So you can have operational cost savings, which includes energy savings. It could be incentive dollars or client capital. So there's a lot of different sources of funding that the energy service company industry has used. So a little bit about our history. So NAESCO was founded in 1983, but the ESCO industry obviously had to exist before a trade association for the organization was founded. It was started in like the 1970s as shared savings contracts. In those cases, they would do a project and each party would share some of the savings of the project. But what happened is in the late 70s and early 80s, energy prices started going up pretty rapidly, and that caused these shared savings contracts to no longer have value because there wasn't any savings anymore. When you share the savings, you're saving the actual dollars, and the contracts kind of became unviable because there wasn't enough savings to cover the costs that they had incurred. And so the shared savings contract lasted for a while. It formed a nice foundation for the industry, but in the early 80s, there had to be a change. And so the industry settled into more of a performance contract, and the savings tends to be based upon energy reduction, not cost reduction, but it's energy reduction translated to cost using the rates at the time of contract. So if the rate changes, the contract no longer is subject to the whims of the rate changes. Since the rate change would happen with or without the contract, you've pulled that risk out of the contract, and it works out very well with both the owner and the ESCO. In May of 1996, NAESCO introduced the accreditation program. I talked to you about the accreditation program. It's a very rigorous program where we go through and talk to references of projects. We review company finances. We review measurement and verification reports. We understand how the project was developed and how it was financed, and we look at any litigation history that each company has. And an independent group does this, NAESCO, myself. I get to see it and watch it, but a third-party group that has autonomy from us does this to assure that there's no conflicts of interest. The size of our industry is quite interesting. There's a Lawrence Berkeley National Lab survey that might show us around $7 billion a year back in 2018. When I ask my members how much in contracts they sign per year, they report about $12 billion in contracts that were executed in 2024. So it's a pretty good size industry. It breaks down to quite a few different kind of clients, and we'll talk about the different markets that we work in. So this is my picture of how a performance contract works. It's in the form of a Sankey diagram. And so you see where you start off in the left in the blue bar, you have the total energy and operational costs. And I've learned today that I have a pointer. I can actually point and show you where it's at. And so this bar represents all the costs that you have today. And then we begin to peel off those costs. We peel those off into a financing payment and an ongoing services and lower cost post-construction. So the idea is you have your energy and operational costs. You do a construction project, which lowers those costs, and then you have lower cost post-construction. But some of those savings are peeled off and are paid to finance the construction, and some of those are peeled off to pay for the ongoing services, which may represent service and maintenance, or it could represent measurement and verification services to validate the savings. When we look at the stages down below, we start out and we see buildings often come to us because they have aging equipment, high cost services, poor indoor environment. There's a lot of reasons that clients will come to an ESCO for this work. That they might be under a mandate from local government to reduce energy consumption or reduce greenhouse gases. And those cases, our projects do help out those. But generally, most of our projects are justified and started because the client sees some need for an improvement of their facility. Our biggest market is K through 12 schools. There's a massive amount of deferred maintenance K through 12 schools. A new report's coming out tomorrow, which I think is going to show somewhere around $120 billion of deferred maintenance in our K through 12 schools that these types of contracts can easily address. If you look at the bottom corner of the yellow area, it shows there's an investment grade audit. And although I show it kind of small in the big picture, it's actually a key linchpin part of the whole process. When you do an investment grade audit, it is not just an audit that you get and you flip through and you say, well, this is nice, and you put it on a shelf. It is an audit that has been developed with contractors involved, and it has firm fixed price. In other words, the ESCO will develop the investment grade audit, offer it to the client, and they'll say, we'll build this project with no change orders because they developed the scope, they engineered it, and they take on all the risk of potential change orders or mistakes. The investment grade audit also carries with it a guaranteed savings. And so that product of guaranteed savings means that if the savings is not achieved through the measurement and verification process that's in the contract, the energy service company will make up the difference either by writing a check, providing some ongoing services, whatever it is the client and the ESCO agree to, they have to make up the difference so that the client is whole. When you do a performance contract, one of the key things about it is that there is no scope when you start. The client may have an idea of what they want to do, but they don't necessarily have a scope like you might bid out. And so there's no way to bid out a performance contract with a scope because the scope is developed once you select your partner. The ESCO would develop the scope, and you select the partner by qualifications, which is why the accreditation process is so important. The ESCO would then, once they're selected, would go through an investment grade audit with the client and make that product be what the client wants to do. So the scope is variable, and there's a lot of input from the client as well as the ESCO to determine what the scope needs to be. Then you begin the construction, that small yellow bar there in the middle. And again, the size doesn't represent its importance. The construction project is key because when the ESCO does that installation, it's key to ensure that the proper equipment makes it into the project. There's no substitutions last minute that might change the energy savings. And at the end of that construction, to ensure that it's commissioned and started up properly, and that whoever's going to maintain that equipment is properly trained to operate and maintain that equipment well to assure the savings continues throughout the life of the contract. That second bar, now it's kind of a light green. In the middle, this area is the performance period. So once construction has been done, you've gone through the punch list, you've checked off the punch list, and everybody shakes their hand and says the project is done, you enter into the performance period. And this is where the savings begins to accumulate. We also, as we accumulate the savings, we have to pay the financing. So the client typically will get some sort of a financing package to pay for the construction, and then that savings will pay for that financing package off over the life of the contract, which could be 15 to 30 years. The savings that we see in these contracts is often somewhere around the range of 25 to 30%. They can go as low as 15%. I've seen projects go as high as 50, 75. I've even seen one go 100% where it had a significant amount of renewable energy installed. But that's pretty rare. 25 to 30 is a reasonable number to expect in the middle. 20 to 30 is very common. Then there might be some ongoing services that are included. Maybe that's for an ongoing service contract. Maybe it's extended warranty. It's more than likely going to include some measurement and verification process to validate the savings. During the performance period, the ESCO works with you to make sure you understand how equipment works, answer questions, and then on an annual basis, typically, they'll do an evaluation of the savings, present that to you, and if there's any shortfall, they'll make a shortfall payment. Most of the time, the ESCOs are pretty good about making the savings on their projects, but it does happen occasionally they'll miss and they'll have to make up the difference. Once that 15 to 30 year contract is completed, then the owner takes all the savings, and those savings then go to accrue to the bottom line. But we have to realize that if you go 15 to 30 years, much of the equipment is probably also ready to be replaced again, and you're ready to do another contract. And so some life will extend, but some life will also probably have to be replaced and new equipment, and you start the process again, maybe with another performance contract, maybe with whatever in 30 years we offer on the market then. So what kind of clients are using performance contracts? So the clientele is, for the most part, public buildings. That's like federal buildings, state buildings, city buildings, county buildings, K through 12 schools, universities, some hospitals. Prisons are often, detention facilities are often a large use for this. But generally, that's where you see these types of contracts being executed. There is a little bit of private use. There's a little bit of industrial use. But for the most part, most of our members are involved in doing public buildings. Public buildings, by our estimate, are about 25% of all the buildings in the country for commercial buildings. So it's a pretty good chunk of the buildings. But we've got two bars here. One of them shows by investment levels. This is by the amount of the money they put into the project. And the second bar is about by the project count. And so over here, you see the top one, the federal government has a big by investment level and a smaller by number. That would tell you that they have larger projects than typical, which would make sense because they tend to have larger, more complex facilities. Think like military bases, scientific laboratories, and so forth. Their facilities tend to be much more complex than, say, a straightforward county courthouse building, for example. In the middle, this big green area, that's our K through 12 schools. That's our biggest market. You can see that their projects would be a little smaller than typical because their green area for the investment level is a little lower. And that would make sense. As you do things like elementary schools, middle schools, they tend to be a smaller size project. And the measures you install in those schools are pretty consistent across the country. They all have pretty much the same types of needs. This next little light blue bar, this is our private sector. There's not a whole lot there. Same with healthcare, not a whole lot there. But the one down below is state and local government, and then universities and colleges. University and colleges tend to be larger than typical projects because they tend to have complex campus type of organizations with a central plant. State and local government is another large building market for us, be the second largest market according to these charts, with federal in third. So it's a pretty diverse market. The buildings have a lot of interesting aspects to them, but this is a breakdown we normally would see in our market. There's a little bit of effort to get more private sector buildings, but not as much as the public sector buildings in this case. What type of things installed? So this is where we get to our eye test today. We test how well we can see the small print. Now this project list was made in 2018. So you have to think, 2018, that's 7 years ago. And you think, well, maybe not that much has changed in 7 years, but actually a lot has. So we've kind of shifted since 2018. We think a lot about resiliency today. These list items have a little bit of impact on resiliency. So let's talk about them. Lighting, energy management systems, variable frequency drives, controls and motion sensors, air handling units, boilers, chillers, lamps, airflow control. Those are the types of things that we had traditionally put in. Today, we do a much more. We think of microgrids. We think of generation, solar, not much wind, but mostly solar generation that gets put into projects. The sophistication added with the microgrid is nice because it allows a facility to make a choice on how much they rely on their outside generation or how much they rely upon the grid to provide their power. In addition, you'll see EVs entering into the scene, mostly with EV charging infrastructure being added to the buildings. So we've changed around this a little bit, and I guess in 7 more years, we'll see a whole new set of ECMs also coming on the scene. But the projects, when they first started in the ESCO industry, really hovered a lot around lighting. And lighting was what you might call the cash cow of the industry. Lighting, if you came in and you retrofitted what was called a T12, which was a 12/12ths of an inch or a 1-inch tube fluorescent light, down to a T8, you saw a significant amount of savings of those projects. And then when we went through the next phase, we took a T8 and we retrofitted that down sometimes to a T5 and then sometimes to an LED. And if you can believe it, now we're even retrofitting from the LED we installed to a newer, more efficient LED. But as you can imagine, each time you do that retrofit, the savings gets smaller. And although you might save 40% each time, 40% of a smaller number tends to be a smaller and smaller number. And so lighting projects can't always provide the cash cow structure of infusing money to cover other things. When you do things like boilers and chillers and even air handlers on top of a rooftops, for example, the payback is a long period and often exceeds the time required for financing. And so you often have to have other measures or some capital contribution to come in and make those work into a project because the savings isn't sufficient to cover the cost of those large capital intensive items. We'll talk about some of that later in project leveraging, but for now, just recognize that there are some measures that provide a lot of savings and some measures that provide a little bit of savings, and the lot of savings have to help the little bit of savings to make a project work.
Hey, Dr. Unruh, I got a poll here. I'm going to launch. You guys, the attendees should all see this pop up on your screen. And I think once you participate, it goes off to the side and you can still look at the results there. But it's most state laws about ESPC allow new construction projects to be included. True or false? All right, great. And you can continue on. They can continue to answer that as you go. And we, if you want to comment on the results, it looks like we're getting a lot of false answers right now.
I'm going to go ahead and answer this question because the original poll that I had 4 answers available on this one. There was true, false, both, and neither. And the reason I included all those answers is because it depends is the answer. Generally, the word is false is probably the right answer. However, some states have some variability in their legislation and might allow some new construction projects, but most of the time they do not. And there's a few states where the interpretation of construction is maybe at issue and not quite clear, and that might be, it could be both or neither. And so it's an interesting question, but generally most energy savings performance contracts focus on renovating existing facilities They don't work on replacing buildings, and they don't work on building new constructions or greenfield constructions. That would probably be like 99% of the cases would be no new construction. So if you answered that they don't allow new construction, you got the answer as close to right as probably we're going to get in this one. So we went over the projects. Look at this slide here. Do you have like a result of how people answered that one, Chase?
Yeah, 32 responses. We got 63% said false and 38% said true.
Okay, so see, there's even confusion there. And probably that ratio is probably about right amongst those that do it and some that don't. So it's an interesting dilemma. It tends to be an ongoing issue in our legislative affairs on how we interpret these things and what happens. But let's just say you really have to understand how the state laws work and what's allowed and what is not allowed. That's the key I'll have to leave you with.
And our audience here is there's a lot of seasoned ESCO professionals, but we also have just general STEAM enthusiasts and facility managers and things as well. So hopefully a lot of people are learning about the potential benefits of these contracts and how they work.
Chase, I love that term, STEAM enthusiast. I'm trying to find a picture what that is. Is that like a person that on their fireplace mantle they have like steam traps?
Yeah, or maybe scale models of locomotives, or all kinds of stuff. So
okay,
but
that's great.
Yeah, just kidding. But yeah, we have a lot of people, Cleaver Brooks people and other manufacturers that are just in the STEAM industry more so than the performance contracting industry, and I think a lot of them will find this information new and interesting, as well as our seasoned ESCO attendees.
Well, good, because I have a Cleaver Brooks squishy sitting on my shelf right here in my office. So, I'm right there with those Cleaver Brooks guys. So let's get back to our presentation here. So we talked about the typical energy savings that we have. We see that there's typically 15 to 25%. I talked about 25 to 30 is something you might want to expect. Duration of project, 15 to 30 years. Types of scope, we talked about those. One I didn't mention is building envelope and water conservation and security systems. Those are things we're seeing more of as we see projects get put together. Building envelope is one that is challenging. Many places need that. While building ceiling can have a pretty good payback. Sometimes if you're doing a roof, it can be a little challenging to make energy payback. Water conservation is a very lucrative energy savings and operational cost savings item to include. And security systems won't have much energy savings. It might have some operational savings, but more and more our members are being asked to look at security systems in the building. Many times we're being asked to look at all types of systems in the building as the school needs to try to move forward with some of their deferred maintenance. So the key thing is there's legislation in all the states and the federal government that allows performance contracts to work. Why we need legislation is because our buildings, our public buildings, are challenged with being able to just enter into a contract that obligates their payment for a number of years. Normally, any type of obligation done by a public entity has to be approved by the voters or by an elected official. And facility improvements tend not to be high on their list. So if you're a school district and you're a superintendent of a school district, you probably want to do things to enhance teacher pay, student environment, more than you want to think about trying to put a new boiler in a building. But as you know, those boilers will fail, and that heating system or cooling system will fail, and eventually will make itself known, and attention will have to be paid. But the legislation allows for the trade-off where you take out the loan and you trade it off with a guaranteed performance. And the guaranteed performance is critical because you're guaranteeing that there'll be enough money to make the loan payment, even if the operational and energy savings does not materialize. That's where the private company steps up to make this possible. So because you have a no new taxpayer dollar approach, you don't have to go get approval, and that's what the legislation allows. It allows for the trade-off of current budget expenditures, pay off the financing contract, so long as there's a guarantee that those current budget expenditures will always be sufficient to make the financing payment, so no new appropriations are necessary for these projects to occur. We talked about the market size as well. K-12 markets is about our largest. Federal is about the same size, a little smaller than K-12. and the remaining falls into state, local universities, and hospitals in our industry. So I pulled out an example of what a performance contract looks like. This is one of our members' projects in Kentucky. It's Warren County Public Schools in Bowling Green, Kentucky. A company called CMTA, one of our members, has done this. They're an accredited company. Just to give you a picture of what this is, you can see in the bottom right corner at one of their photos, this is a ground source heat pump installation. And you can see they had to do some work on the facility there, and they had to make some improvements and made a contract that was about $36 million. They had a guaranteed savings of 1.18 million, actual savings 1.3. It was several phases long, and it had, I like this stat, 105 miles of geothermal piping. So let's take a look at this.
We got another poll here.
Go ahead.
Launching now. So the poll is: the passage of the One Big Beautiful Bill on July 4th, 2025 doomed most ESCO building retrofit projects. True or false? All right, we're getting responses in. We got about 30 responses so far. 83% or so are saying false, and 18% saying true. You want to give us the real answer there?
The real answer is false. The One Big Beautiful Bill Act really made a rescinding of many of the Inflation Reduction Act tax credits. And while maybe you call it fortunate or not, the Inflation Reduction Act had large tax credits for renewable power and ground source heat pumps, but it did not have anything very large for efficiency. There is one piece that was very important to us called 179D, which is a tax deduction. And while we lost 179D, it wasn't so large that it had a massive impact on projects. And when the One Big Beautiful Bill Act passed, it did rescind the solar credits, but solar tended not to be often the driving force in our projects. There might be a few, but for the most part, solar was often small if it was included at all. But what was a big part was the ground source heat pumps. The One Big Beautiful Bill Act did not rescind ground source heat pumps. And so if you look at this particular project, there is a federal tax credit of $1.7 million included that helped pay for this project. And that would still exist today and tomorrow under the results of the One Big Beautiful Bill Act. Those are still present in the same level that they were before, and they have not been hindered in any way. So that's a great opportunity for our market, since K through 12 schools are very large in our market, and those are often a very good candidate for ground source heat pumps. They have the field availability, and they have the need for air conditioning and heating in their buildings. But I want to go back to the top here on the energy and operational savings. You know, there's the annual savings that they projected, and then once they did some measurement and they evaluated the project, they actually thought they're going to get another almost $250,000 more in savings. That's a common result in our projects, that as you see things occurring, you can optimize them for use. And if you project manage and performance manage these sites, you can often take the savings even beyond what you discover at the end of construction and save even more money over the life of the project. This project also had a grant from Kentucky Energy Environment Cabinet for $375,000. We talked about the federal tax credit. And what's important about bringing those out and talking about those, small or large, is the energy service company is critically important in finding these, figuring out how to fill out the forms, and helping the client make the application so that these can occur. These are often very complex subjects. Think about a school system doing a federal tax credit. They never file taxes, haven't ever done that before. And all of a sudden they have to figure out how to do taxes. They have to determine what their tax year is. There's so many things that they have to do. The energy service company can provide a lot of the backstop to help them get through that process. Clearly, there's other consultants that come in. We have members who do tax credits and help with some of these things, but the energy service company is really coming alongside the owner and helping them to take the project from zero to completion in whatever way they need to, with finding the money. There could even be some capital money in the budget.
Hey, Tim,
Yes.
speaking of finding money, we do have another poll. I'm launching now. So, and there's only one more of these after this. I know these are kind of close together, but how often do ESCO projects include utility rebates and incentives? The options are every project, no projects, if the client pushes for their inclusion, or if the business development person pushes for their inclusion. And I think you're referencing the representative from the ESCO as the business development person.
Let's see what the answers look like.
Right, we got 19 responses so far, 29 responses. Okay, so the leading answer at 43% is if the business development person pushes for their inclusion. Second place is if the client pushes for their inclusion. And third place is every project. That's kind of my ranking.
Okay,
of
so
those
that means
answers
43% of our audience, if the business development pushes for inclusion, that's the engineers on the audience who said that. That's because the salesperson says they've got to do this. If the client pushes for inclusion, those are all the salespeople on the call because they're the ones talking to the client. And every project, well, those are our Pollyannas. I love them. They're the ones who are making sure that everything's always positive. Actually, the answer to this question is anything but no projects. Almost every project has some other type of money that comes into it, is the key for this answer. While different people will push for different things to be included in the project for different reasons, the business development person obviously wants to get that additional money coming in because it helps their project grow and they can provide more value to the client for the same reasons. But a lot of times every project will have something in it. You just never really know. But the key is no projects is the wrong answer. And all the other answers are perfectly acceptable in equal fashion. So let's talk about project leveraging when we talk about all this money coming in projects and where they come from. So when implementing a performance contract, other sources of funds can be capital money already in the budget. And we don't want to overlook that because we'll see in the next couple of slides, leveraging offers a big opportunity for that money to go further than it would have alone. Utility rebates are often in the projects. Federal tax incentives are in the projects. State and local grants can be in the projects. We saw in the last project, all these were in there. I see federal tax incentives and state and local grants are in there. We didn't see utility rebates or capital money, but those are also available for projects. One of the tempting things to do is if you have money, for a client to have money and to just go out and spend it. It's easy, it's fast, you've got all the systems in place to do that, and there's no problem in making that happen. But if you step back and take that money in hand and try to combine it with a performance contract, you can leverage that money so that $1 that you get from all these other sources plus $1 in energy and operational savings can equate to more than $2 of facility improvements. And so if you combine these things together, you'll find that you can get a leverage somewhere between $2.4 and $3 is what we think you might be able to get from taking $1 of a performance contract and $1 of capital money to combine those together. And we'll show an example of how that works. But the key thing to remember is just don't go out and spend your money by itself. Combine it with the savings to make the project go further. So this is a project I did many, many years ago when I was an ESCO engineer. And so the numbers are clearly outdated and it doesn't really matter the scope, but it's about a $2 million project that the client was planning to do in their facilities. And they had about $2 million to make this all work. And if we look at this thing, it's not financed at all. They're just going to pay for it. And it's got a payback of just over almost 44 years payback. So it's not an energy project. It's a capital project, but this is what they wanted to do. And they had the money in hand to do it. We came in and we saw a performance contract that we could come in and work with them. And it's about a $2 million project also, just by chance. And it has enough energy savings to pay back in 9.56 years. And I don't know what the financing rate of this particular project was, but normally when you do these projects and you put them together, you've got to look at the payback period. It has to be less than what they called the financed payback period. And in many of the projects, if it's a 20-year project, you might think about 11 years or so is about what you get. And interest rates today might lower that or change that a little bit. But about 11 years is often your goal for simple payback to make a finance project work. In this case, if they take that capital, that $2 million that they had, and they leverage that with the performance contract project, to do both of them together, you only need about 1.1 million of capital to get the full $2 million of capital projects and the full $2 million of energy projects put together into one project. So let's look at what happens if you combine those. So this is the list, again, another eye test for you of all the projects together combined. Now, the total cost is a little bit different because when you combine them together, you have a little bit of savings in the other project fees, on-site project management, and so forth, that the estimating tool will reduce those costs because you don't have to have dual. They can be combined assets as they cover the projects. The bonding is a little bit different and so forth as they come together. But overall, this came out to be a $3,788,000 project. And if they do the $1.1 million cash contribution, that makes the project financing about $2.7 million. And so the first payback is the payback with just without the capital contribution of 14.73 years. And that would be greater than our finance ability of about 11. So that won't work. If you combine that $1.1 million capital contribution and you get a payback of 10.45 years, we now can make the financing work. And this is financeable over the term, which I think in this case was 20 years. And so you took that project and you have $900,000. Now you can still spend on other things. Generally, what you would do in a project like this is you take that $900,000, you continue to add that to the performance contract, and you would end up with more than $900,000 of additional work. Just like we leveraged the 1.1 million, you'd continue to leverage that 900,000 to make the project even more than it is today. So that leveraging helps a project grow well beyond what you might have done if you just did each of them as two independent projects without doing them together. And in 2003, a guy named John Schonder worked at Oak Ridge National Labs along with Christine Walker, and they did a study and put together a result that talked about how that leveraging works. And if you take this particular one here, this is the performance contracting project, and here's the energy project or the customer funded project. Now, in this case, they show the bar really big here, and this one a small bar. In my case, I showed them about the same size. They were about $2 million in each one of those. When you combine those together, they're showing this bonus project up at the top here of effectively a little bit bigger than the capital project. And that's about what we saw in our project. We saw that additional project that you could gain up here at the top. And so this shows that you can actually achieve leveraging and that the leveraging is real. And so we've got some confirmation now from a national lab that leveraging these projects does add some additional projects that you wouldn't have gotten before. So it does make sense to always take your money and combine it with an energy project. Don't just let it be spent alone.
Hey, Tim.
So with, yes.
If you're done with this slide, we got another poll here before we jump into the next section. So this question is, the solution to grid instability with renewable energy rests solely on batteries. Is that true or false? All right, we got responses coming in. I'm seeing 23 responses so far, 33 now. We got a 97% response rate of false. How do you feel about that?
Got a pretty good audience here. So the answer to that is false. The solution to grid stability lies in a whole mixture of technologies. Batteries are certainly going to be a major player, but they're not the only player. It turns out, as you look at the studies, to take batteries as 100% of the grid stability solution, it's always the case that probably 80% will be covered easily with batteries, but that last 20% becomes so cost ineffective with batteries, you need to find another approach. And so one of the approaches that I like is called grid interactive efficient buildings. Grid interactive efficient buildings, or GEBs as they're called, is about using a building to provide input to the grid to provide stability. So if you feel that renewable power is dropping, as a grid operator, you can call upon buildings to change their load pattern to perhaps scale back their energy use for a period of time. If you have a modern, efficient building, you can often scale back the HVAC and allow the building to float for a period of time. And because it's insulated properly and designed properly, you can still keep occupants comfortable within a little wider set point range than what you might have used. At the same time, if you think there's going to be an overproduction of energy, like you have more solar on the system than you would expect, you can also cause the building to perhaps pre-cool so that it can ride through when that eventually does go away, because as we know, the solar and wind vary through time. All that can happen through the coordinated control of the building management system, and the operator and the building occupants often won't even be aware of it. But grid interactive efficient buildings do provide a lot of ability to shift load, modulate the load. You can even use it to control generation that the building might have. I think I saw there were some thoughts that maybe using the backup generation at facilities to provide some of this support could also be out there. I think DOE mentioned that recently. We'll have to see how that goes. But the idea is that GEBs can provide some coordination of the buildings to help the grid.
Hey, Tim, we got a
Yes.
question here. How is the legislation in the U.S. to accept or even grant those grid interactive efficient buildings? Europe is moving fast and has a strong legislation in some countries.
Well, I think our weakness here in the United States is our rate structure to include the potential of grid interactive buildings. And the second weakness is, I think, interconnectability. You're right. I hear a lot of exciting things about Europe providing some of this access, but they still suffer from the interoperability type issue, getting the buildings to coordinate with the utility systems and so forth, or getting many buildings to work together. I don't know their rate structures in Europe and how they support this, but our rate structures are still evolving that can support this and make this a profitable venture for companies like ESCOs to provide their buildings into a model like this. So another piece of the future is energy as a service. There's not a lot of energy as a service happening right now, but there's a lot of people talking about it. Energy as a service is a little different business model, and it's effectively coming in where there might be some ownership of the building assets by a third party, providing a service that comes in for the client that they pay for, with key performance indicators that assure that the service provided meets the requirements. It really is an outsourcing of the energy operations of your facility to a third party. It's related to P3s, which are public-private partnerships, where a government entity enters into a partnership with a private company, except that energy as a service is being done quite commonly by private sector buildings. So you see a lot of our companies doing private sector building work. We have members whose sole work is with private sector buildings doing this type of effort, energy as a service, where they'll come in, replace the equipment, operate it, own it potentially, and they'll pay a fee, will be paid by the client to the energy service company over a period of time. And the energy service company assures certain operational parameters will always exist. And then kind of fast forward that to our version in NAESCO. We call our version of this energy as a service a SCIP, Sustainable Capital Improvement Project. We believe that in most states, there needs to be legislation, just like for performance contracts, we need legislation for the Sustainable Capital Improvement Project, or SCIP, in order for a government entity to turn over these assets inside of a building to a third party to own and operate and manage. And instead of paying for energy and equipment, they're paying for performance of the service through key performance indicators. We're working real hard to get that passed up in Pennsylvania. We think there's a good opportunity in the nation for this to come across. We've gotten clients that are interested in this, and we've seen a lot of energy service companies interested in this. But right now, it's just still a small piece of the industry. But we have a lot of excitement about the future of where this can go. Some of the key things of why we think it's important, a client can do this with no upfront costs. They don't finance because the third-party company takes care of all the money requirements. It's an off-book financing method. So a school district doesn't have to get a bond. A university doesn't have to go into their endowment fund. The money is provided from outside sources to make all of this work. And it provides a turnkey solution for energy efficiency, greenhouse gas reduction, building improvement, indoor air quality, all the things a performance contract can do, only the money is different and the performance guarantee is different. With that, I'll turn it back over to Chase.
Hey, thanks, Sam. That was really great. We do have a few minutes. If anybody has any questions, feel free to post those in the chat. On behalf of everybody attending today, we want to thank you, Dr. Unruh, for the presentation. It was very interesting, and we're very grateful to have you on. For the attendees, you can scan that QR code there. I believe that takes you to the registration page for our next webinar, which is on blowdown heat recovery. This is a steam system, ECM, or energy conservation measure, that we love. It can be a great opportunity when the conditions are right. But yeah, we're going to do a webinar on that, and that will be in January. January 20th specifically. Also, the bottom left QR code takes you to where you could schedule a technical presentation for your team. So that's for, I'm not committing Dr. Unruh to doing this, but that's for an SMI representative to do a presentation for your team, most likely me. And you can also access our past webinars and future webinars at steammgt.com/webinars. All of these, including this one, once it's ready for prime time, will be, I guess syndication. It will be back on our website there, so you can access this again. Okay, we do have a few questions here. Can you share out the presentation? Yes, we can share the slide deck. What we normally do for requests like that is you just email me. My email is cbean@steammgt.com, and we're happy to share the slide deck. We also have certificates for completion as well. Yeah, so those are available. Just email me. I just put my email in the chat. Okay, next question. What happens to assets after the duration of the contract in a SCIP or energy as a service project?
Well, that's a great question. It could be anything that the contract planners decide at the beginning. It could be that there's an option to continue the contract. More than likely, the contract duration is such that the equipment life may be nearing its end, and you may need to do a secondary project to renew that equipment. Generally, in an energy as a service type project, there is some responsibility that the ESCO or the party involved would take a responsibility to repair and replace that equipment. If it fails prematurely, they have the full responsibility to replace that equipment. At the end of the project, if there's still life left, they would then work with that client probably to try to do a secondary project and follow on, or a secondary project that renovates the project. Or it could be that they decide to part ways, and that equipment then may have a buyout clause at the end of the contract. It just depends on how they set the contract up at the beginning.
Somebody commented that they work in energy as a service, and they actually give the asset, I guess, to the client after the completion of the term at terminal value. So that's one way to do it, right? It's whatever your contract says. So if you're a facility manager in the audience and you have some needs, what are some indicators that you might want to take on one of these performance contracts or other mediums that we discussed?
Well, when you look at the opportunities of why you want to choose these, clearly, if you are in a financial bind and you are struggling with how I would finance a project like an energy savings performance contract, then the energy as a service SCIP project would be appealing to you because you don't have to finance that project. The challenge would be is do the laws and legislation in your area for a public building allow you to do this. For a private building, you can go forward with it very quickly and easily. The the choice is really on how you want to run your facilities, how much responsibility you want to keep in your facilities, and how much you want to outsource. That's really what the main decision point comes to these types of projects.
I think it's so interesting how, you're taking like maybe your initial funding and then you have a consultant come in and they do all of the development as far as identifying all the measures, all of the research on other sources of funding, if it's grants or utility rebates or whatever it is. And then they loan you the money. And then in the end, you still save money. I mean, it kind of, to me, it feels like a no-brainer. I know that there's been performance contracts that have gone sideways. But if you have like potential energy saving scopes on the table, leveraging those to improve your facilities as far as possible seems like a great idea in a lot of scenarios to me.
I think that's right. I think the opportunity to bring in expertise, if you're running your facility, you have as much knowledge as your staff can bring to you. But when you hire an energy company that provides energy as a service on a regular basis to whatever entities are provided to, they have a lot broader background and a lot broader resource pool to come in and try to help understand how the facility can be operated as best as it can be. I think that's why this makes sense. It's a general trend you see in companies where they're outsourcing things that are outside their core competency. So if you're a K through 12 school, for example, and your core competency is training kids, one of our attendees posted that they provide energy data as a service to K through 12 school districts. I think those are great. We've seen these types of service contracts. In a sense, think of your copiers. Your copiers come in, that piece of equipment is owned by someone else. They have to repair it, maintain it, and keep it operating, and you pay them based on the number of uses the equipment has. And energy as a service is very similar. It's just more complex in that there's a lot more key performance indicators than number of copies. The key performance indicators have to be response times when there's an outage, interior temperatures, interior air quality, lighting levels. There can be all types of key performance indicators that have to be maintained. And it takes that responsibility off of the facility manager and facility owner. They can focus on what their core competency is, as opposed to trying to run a facility which may not be their core competency. I mean, I think when you look at our public buildings in particular, because that's the area my members mostly work in, public buildings have a challenge in that they often have funding challenges, getting enough money to keep their facilities operating. And then they probably have challenges keeping staff, because staff, once they become competent, can probably make more money somewhere else than that public building. And so you have that double whammy challenge that makes it a great opportunity to have a third party come in and manage and maintain that, so you have a more efficient operating system.
Awesome. Well, we got about 2 minutes left, but if there's no other questions, I think we can call it good. And I hope everybody else appreciated the presentation. I certainly did. And we thank you again for joining us and presenting today. And we hope that you will all join us again next time on January 20th. So we're going to call it, and we hope everybody has a great week, and we'll see you next time.